In the previous video, we're able to identify the derivative of this given function using a definition. Here is that page. Okay, actually, we have two pages before. Using a definition, the given function and its derivative was actually identified as 5i, this one here, 5i all over z squared plus 4iz minus 4. If you would like to know again or review how it is done, try to view the previous video in this playlist because we actually took 2 pages for this one because a lot of processes are involved, especially that our given function is a rational function. Now, for this video, we are just tasked to solve the derivative using a definition. But it's not necessarily using a definition, but since this is continuation to that video, that's why we had here using a definition. But of course, if you are going to solve a derivative and you know rules on differentiation, you can also use the rules on differentiation in getting a derivative to solve for it. Because basically, the solution process, this is our function here, 2z minus I over z plus 2i. Your first derivative, again, is identified, if I'm correct, is 5. Was that 5i over z squared plus 4iz minus 4. Okay? Over, that's 5i over z squared minus 4iz plus 4. Again, let's do it again. Z squared plus 4, plus 4iz and then minus 4. Okay? Plus 4iz then minus 4. So let me do this one. Plus 4iz minus 4. Okay? The purpose of this video is simply substituting the value at z equals -1 because we already know the derivative of the given function, regardless of whether it was solved using definition or any rules on differentiation. So basically, this is just short. I'm just trying to review the previous video that you will be able to understand how it is done. And of course, you have the video here. You simply view that on your own time. Substitute here z, -1 squared, plus 4i times -1, and you have here minus 4. Okay? So basically, just like that, simply simplify that. You will have here 5i over -1 squared is 1. You have here minus 4i. And you have here minus 4. Or finally, you will have here 5i over, that's -3 minus 4i, arranged in a manner where we write the complex number, starting with the real part and then the component or the term with the imaginary unit. This is the answer to the item. This is the solution for the derivative of the given function at z equals -1. Okay, so if your professor would just accept this, then it's okay. Of course, if you are also asked to determine the value of this where there are no imaginary unit in the denominator, you can also simplify that using the conjugates. Right? Okay, I'm going to show you how it is done using conjugates. So you have here -3 minus 4i. We can multiply this with -3 plus 4i so that our denominator will no longer contain the imaginary part. We have here conjugates. Okay, same first term, same second term, but different operations separating them. So that's actually 5i times -3 plus 4i. And you will have here difference of two squares. The square of the first term minus the square of the second term, which will give us -15i. -15i plus 20i squared all over 9 minus 16i squared. We know that i squared is -1 because because I is square root of -1. That would mean you will have here -15i, then plus 20 times -1 over 9 minus 16 times -1. Right? So you will have here the result of -15i minus 20 over 9 plus 16. Plus 16. Sorry, I was telling earlier this would be shorter because I did not expect to show the solution or simplified process without imaginary denominator. You can stop at that portion until here, but let me continue this one because I already started this. So you have here -20 minus 15i over 25, factoring 5 because you can also factor 5 the denominator. So you have here negative 4 minus 3i, if I'm correct, over 5 times 5. So your final answer here, if your professor would require you to do this, is actually negative 4 minus 3i all over 5. This is the more simplified answer to this solution here, but this is already acceptable as it is. So you have that as our final answer. But basically, this is the solution of the given function using already the solved derivative using a definition. Thank you very much for watching.